Okay, so we have derived our seismic inertial forces at each level, which is the Fi values, and then we're going to distribute the Fi to each of the floor to the walls, onto the walls. So how do we do that? So by 1170.5, we have a 100% direct shear. This is the 100% of the Fi that is going to be acting in north and south direction, which I point in the right here. But we also got a plus minus 10% of the accidental eccentricity. That is accounts for some uneven mass on the floors or walls. That is just accounts for 10% of that. That B is the width of your Fi that is perpendicular to it. And on top of that, we have a 30% of eccentricity that we have to account for when it comes from the other direction. The reason for doing that is because think about this, the earthquake does not pick a direction, right? The earthquake is going to go hit the building at any direction as it wants, correct? So this is 30% is what we conserve as a conservative approach, is to say, hey, I've got another 30% direction and 100% direction in an orthogonal manner, just accounts for the bidirectional effects. I hope that does make sense. Okay, so how do we distribute that? So as you can see here, I've got an example. I've got a few walls and a floor plate with a void, and I've worked out the center of mass and the center of rigidity. So based on that, we can see that the floor plate is going to rotate at the mass point from the rigidity point. It's going to rotate. It's going to rotate clockwise, like this, clockwise, and anti-clockwise, right? It's going to rotate like that. This is going to be one way or the other. And for the eccentricity, for any eccentricity, it's going to rotate clockwise or anti-clockwise. It can't rotate any otherwise. It can't flip. It cannot flip. Okay, let's assume the floor plate does not flip. Okay, so how do we do that? So I've got a 100% and shear force directly heading to my building, and so that direct shear to be distributed for A, wall A, and wall D, because that's a line. That's easy to understand, right? For my 10% eccentricity, accidental. So I've got a 10% eccentricity, accidental eccentricity. So how do I do that? So my 10% eccentricity, as I said before, the eccentricity, the rotation of that is going to be clockwise or anti-clockwise. That's it. So you can see my purple color here. So first the case I'm analyzing is the clockwise eccentricity. I'm going to rotate this way, right? Okay, let's jump on to my neighboring diagram here. My eccentricity is rotating anti-clockwise, right? So it's going to be one way or the other. So I got my both cases covered, right? So the same thing applies to my 30% extra eccentricity comes from the orthogonal direction. So what if the earthquake, a little bit earthquake shaking from here? So my 30% eccentricity is going to be rotating at the same manner. It's going to be clockwise and anti-clockwise. So my first diagram here, I got my clockwise and jump onto my neighboring diagram here. It's going to rotate anti-clockwise. It's one way or the other. It's got to be. So I got my case one, first case one here. So I got my, if you see, track my color of the forces. So 100% eccentricity I've got sheared by wall A and D. And my 10% eccentricity heading the floor plate is going to rotate clockwise. So follow my arrows here, it's going to rotate here all the way around those walls. So my wall A's got, my wall 1 and 2 is following my force flow. It's going to rotate. So my purple arrows are going to be additive to A, additive to 2, and additive to wall A. So because they are the same direction as my 100% eccentric, 100% direct shear, and the same thing for my wall 3. But however, when it comes to wall D, it's going to be subtractive because it's acting counterwise to my wall D. So, and onto my 30% eccentricity. It's not a direct shear, it's a rotational force. So I have to follow my arrows here. So it's going to be, so my floor plate is rotating the same way as my 10% eccentricity. So my arrows follows, okay, clockwise. It's going to rotating, circling around my floor plate this way. So I got, additive to my wall A, additive to my wall 3, to my D, and then 2 and 1. So instantly you can see which case is my worst case scenario, which is wall A, right? It's because wall A is subject to 3 forces: my 100% direct shear, my 10% accidental eccentricity, and my 30% of eccentricity in orthogonal direction. So wall A is my worst case scenario. Alright, let's jump on to my diagram here, the case 2. The only change is that my because my 30% eccentricity can comes from either direction, whether from west to east, and it can come from east to west. So just to swap that to my east directions. For example, supposing my earthquake heading, my building from my right hand side, from east to west direction, and also my 10% eccentricity, it's got a plus minus sign because it's acting as either plus minus, meaning that it's either clockwise or anti-clockwise. It's the same thing for 30%. I should probably do that as well. I should say, get my green color. So I should probably say a plus minus 30% and a plus minus 30% makes it clear. So my 30% can comes from east to west direction is going to rotate anti-clockwise. So in this case here, I'm going to just call it negative 30%. And in this case here, my 10% eccentricity is going to be negative as well. So it's going to be counterclockwise. So just to follow my arrows, it's going to be rotating counterclockwise around my building. And you can see that as it follows the same methodology, you can see that which wall is having the worst case loading scenario, which is wall D. You can see the 3 arrows pointing in the same direction. So wall D is getting my worst loading case. So this is this case 1, and case 2 is analyzing when the earthquake is heading north and south direction, my 100% is heading the same direction, right? Both heading from north to south. Oh, sorry, north to the south direction, heading towards the same direction. And secondly, my eccentricities for 30% orthogonal is heading from sideways, plus my 10% eccentricity is heading on to my building from north to south direction as well, but as I explained before, the 30% and the 10%, they are using the counterclockwise and clockwise direction because they are rotating this, they are circling this building in a clockwise and anti-clockwise manner. I hope that makes sense. Okay, let's look at another other cases, and I'm hoping this could make clear. So right here, so in this case here, a little bit different is that I had my earthquake loads that is heading from north to south direction, and it's the same thing. My 10% eccentricities always stick to my 100% direct shear, and my 30% is always heading my building from sideways. So you can see that as my eccentricities 10% and 30% is going to acting clockwise on the case 3 and anti-clockwise. Oh, sorry, clockwise, anti-clockwise on case 3 and clockwise on case 4. So eccentricity, remember, eccentricity is always heading the building in 2 directional manners, clockwise, anti-clockwise. So what you can do is just draw your arrows, clockwise and clockwise, and then follow the arrows. So you got purple, 10%, that is anti-clockwise. Okay, I just follow my angle, is circling my building in the anti-clockwise. And my green 30% is circling my building anti-clockwise. And the same to my max case 4 here. I got clockwise eccentricities. So for my 10% is going to be circling my building clockwise, and my 30% is going to circling my building clockwise as well. So by doing this arrows, you can tell that for case 3, that on wall A, I got the most worst case scenario. And for my case 4, I got my D is the worst case scenarios. Right? Okay, there are another 4 cases to be analyzed that follow the same manner as when your earthquake is going to, if the earthquake, the 100% it cannot always be heading north to south direction, and it can hit the building from east to west direction here, 5 and 6, and west to east direction, and here east to west direction. So it's a swap. So your 30% is going to be swapped as well. Is 30% is going to hit the building from north to south direction and south to north direction. So what you can do is, first of all, draw your 100% direct shear is going to be direct shear. So there's no notation for direct shear. And for eccentricities, as I explained numerous times, the eccentricity is going to be a rotational counterclockwise or clockwise in one way or the other. So you draw your eccentricity in clockwise on case 5, and you'll be drawing your eccentricity cases for anti-clockwise on the case 6. So totally got 8 cases to be drawn. So once you've drawn all your arrows, you'll be able to tell, okay, for each case I got a worst case scenarios, and you would get 8 possible worst case scenarios for a wall, and based on that, once you calculate your forces to be distributed based on the stiffness, and ultimately for the whole floor plate within these 8 cases, you've got only 1 worst case scenario for one wall. So that wall you're gonna just design for the forces for the M, for the V, and for the N star. Okay, so I'm hoping this could make eccentricities approachable. If you've got any questions, just comment below. I'll see you on the next video. Thanks.